Now, for very low concentrations, such as environmental toxins and things like that, we actually end up with units like parts per million or parts per billion. And what we're doing is, we again have grams over milliliters, but we now multiply it by million or billion as appropriate. So for example, if I have a fluorinated water source and I have 35 milligrams of NaF per 2 times 10 to the 4 liters, the number of ppm, okay, is the mass of my solute, so NaF in grams, over the number of milliliters of solution times 10 to the 6. So let's go through this. I have 35 milligrams and I convert this to grams. So that's 1000 milligrams in 1 gram over milliliters of solution. So I have 2.0 times 10 to the 4 liters, and I convert from 1 liter to 1000 milliliters. Now I multiply all of this by 10 to the 6, and this gives me 0.0175 ppm as my concentration. We can also use ppm or ppb, okay, as a conversion factor to solve problems. So here we're going to solve for the number of grams of calcium 2 plus. And what does parts per million mean? It really, a corollary to this is that it is the number of grams per 10 to the 6, i.e. a million milliliters. Okay, so let's see. Here we have 110 liters of hard water, and we convert this to milliliters. So 1000 milliliters in 1 liter. Okay, and then we go from milliliters, so we then use this as a conversion factor. So in every 10 to the 6 milliliters, we have 90 grams. And therefore, if I go through the calculation, I will find that the mass of calcium here is 9.9 grams.